For this project, I've chosen the topic of invasive species identification and management planning. It revolves around establishing the ecological impact that common and invasive species have in a particular natural area and their effect on native species. Furthermore, my topic focuses on management methods for these species, coupled with my proposal for a small-scale removal project based on existing effective approaches. Regarding my activity, I first searched for a suitable local natural area that had an appropriate level of biodiversity. From there, I utilized field guides for invasive species, as well as referenced credible online sources, in order to properly identify whether the species I observed were invasive or not. Even though I was unable to find any invasive animal species, I identified three common invasive plant species, which were Siberian elm, ground ivy, and the beefsteak plant. The first species, the Siberian elm, is a deciduous tree that originates from East Asia. It poses two primary issues. For one, the plant has a high germination rate and rapid growth, in conjunction with its wide tolerance range in harsh conditions. The adaptability of the Siberian elm enables it to outcompete and dominate native species. Its presence is especially apparent in areas with low plant density. The second threat that Siberian elms pose is that they can alter habitats to a certain extent. When these plant species is densely populated in an area, it can reduce the sunlight other plants receive. This is detrimental to species that are shade intolerant and animals that rely on these species for food. The second species, ground ivy, is a perennial creeping plant that was brought over to the US from Europe and Asia. In the past, it was utilized in Oriental medicine to treat various conditions. Apart from that, this invasive species is similar to the Siberian elm in the sense that it can grow rapidly. Ground ivy primarily grows in dense, low mats via vegetative spreading, meaning new plants can arise from the vegetative parts of the original plant. This method enables it to skip germination and grow faster than plants that rely on seed propagation. Furthermore, ground ivy has a high adaptability and can survive in various environmental conditions, but ideally thrives in damp, shaded areas. Another issue with this species for native plants is that it can utilize allelopathy, which essentially lets it release chemicals that suppress plant growth. The final species, the beefsteak plant, is also native to Asia and is an annual herbaceous plant. In addition to that, it shares several parallels with the other aforementioned invasive species. For one, the beefsteak plant produces a substantial amount of seed, approximately around 1,000 to 1,500 seeds per plant. These seeds are generally dispersed through wind or human activity. Furthermore, its seeds possess high viability and can still germinate after several years under the right conditions. This form of aggressive self-seeding enables the beefsteak plant to grow rapidly and form dense patches, outcompeting desirable native plants. In conjunction with self-seeding, this species can tolerate and survive in many soil types. Other than that, the beefsteak plant can disrupt established food webs since it contains various volatile compounds such as perilla ketones. Its toxic properties can cause atypical interstitial pneumonia, where the lungs fill with fluid and lead to reduced oxygen levels in numerous common herbivore species. As a result, most animals tend to avoid the plant, giving it an even greater advantage against natives. In order to effectively manage their activity in an area, I would propose a small-scale removal project that involves manual, mechanical, and chemical methods. Once a natural area has been selected, volunteer groups will be assembled along with the necessary tools. First, the group should focus on hand digging and pulling up the seedlings and smaller plants, being mindful of soil disturbance. For larger infestations of ground ivy or the beefsteak plant, regulated application of the herbicide glyphosate appears to produce the best results. Regarding established elm trees, they should be cut and followed up with some form of chemical treatment, such as glyphosate or selective herbicide. When applying herbicides, it is crucial to minimize exposure to native plants and runoff by using the appropriate application method. After the infestations are managed, the area should continue to be monitored as volunteer groups remove any new seedlings that have grown. Overall, the removal project spans several years to ensure that targeted species are entirely removed and do not regrow.